Hello again, grade 7. We are going to complete the new lesson. Chapter 22, lesson 1, part 2, electric charges and electric forces. Now, we are going to talk about electric discharge. Objects can become electrically charged. An electrically charged object, as we said, tends to lose its unbalanced charge after a period of time. The loss of unbalanced electric charge is an electric discharge. So this is the definition of electric discharge. When we have an electrically charged object, it will lose eventually the unbalanced charge. This is the electric discharge. Now, some electric discharges happen slowly. For example, electrons on negatively charged objects discharge or move from the object onto water molecules in the air. You might have noticed that the static link of electrically charged clothing lasts longer on dry days than on humid days when there is more water vapor in the air. I also have some electric discharges that happen quickly. For example, lightning is the sudden loss of unbalanced electric charges that built up in thunderstorm clouds. Now, electric insulators and conductors. Different materials become electrically charged as they come in contact. With some materials, charges remain where the materials touched, and with other materials, the charges evenly spread out over the object. So I have two, in figure A, I have two balls. One of them is charged, the other is neutral. Now, if you put the metal between them, they will split equally among the two balls. But if you put wood, if you make them in contact using wood, a piece of wood, nothing's going to happen. The charges will stay in their place, which means that the metal is a good conductor of electric charges. So after a balloon touches a sweater, the electric charges will stay in the area of the balloon that touched the sweater. However, after you walk across a carpet, charges from the carpet spread over your entire body, and your hand receives an electric shock as you reach for a metal doorknob, as we said in the previous video. Now, electric charges do not spread over the balloon because electric charges cannot easily move in rubber. A material in which electric charges cannot easily move is an electric insulator. Plastic, wood, rubbers are all insulators. So I have here in this figure, I have 5 electrical conductors: silver, gold, copper, steel, and seawater. And I have also insulators. I have rubber, glass, oil, diamond, and dry wood. Now, a material in which electric charges easily move in is an electric conductor. Some of the best conductors are metals such as copper. Now, if you look at this figure, I have examples of insulators and conductors. So the boots, for example, it's made of rubber. This is why it's an insulator. I have also glass, which is an insulator. I have wood, which is insulator. Carbon rods, insulator. I have a metal ring, which is a conductor. Electric fields and electric forces. Suppose you rub 2 balloons on a wool sweater. Electrons transfer from the sweater to the balloons. Both balloons become negatively charged. The sweater becomes positively charged. You notice that the sweater attracts or applies a pulling force on the balloons. However, the balloons repel or apply a pushing force to each other. The force that 2 electrically charged objects apply to each other is called an electric force. Electric fields surround charged objects. To open a door, your hand must touch the door to apply a force to it. However, an electrically charged object does not have to touch another charged object to apply an electric force to it. If you can remember, when we learned the lesson concerning forces, we said I have 2 kinds of forces. One is a contact force. The 2 objects should be in contact, and the other one is a non-contact force. It means An object can apply a force on a second object without touching it. This is a case of a non-contact object. For example, the two charged balloons in the previous example repel each other even though they do not touch. How do charged objects apply electric forces to each other without touching? The answer is a bit mystery. However, scientists know that there is a region around a charged object that applies an electric force to other charged objects. This invisible region around any charged object where an electric force is applied is called an electric field. So this is the definition of electric field. It's the invisible region around any charged object where the electric force is applied. The electric force depends on the type of charge. Whether an electric force is a push or a pull, it depends on the types of charges on the objects. So if both objects are positively charged or negatively charged, it means they have a like charge. The two objects push each other away. In other words, objects with the same type of electric charge repel each other. As you can see, I have these two rods. In the first example, they are both negatively charged. So as you can see, the arrow says that the rod up is going to push itself away, whereas in the second photo, it's going to come closer. Now, if one object is positively charged and the other object is negatively charged, the two objects pull each other together. In other words, objects with opposite types of electric charge attract each other. So as you can see, negative and negative, they repel. Positive and positive, they repel. Positive and negative, they attract each other. So two positively charged rods repel each other. And that's it. Thank you, grade 7.